Welcome back. This is Saxon Math Lesson 11, Problems about Combining and Problems about Separating. So this is a new concept, but like many stories that you read in books, many of the stories we analyze in mathematics have plots. We can use the plot of a word problem to write an equation for the problem. Problems with the same plot are represented by the same equation. That is, we say there are patterns for certain plots. So many word problems are about combining. So here's an example. Before he went to work, Pham had $24.50. He earned $12.50 more putting up a fence. Then Pham had $37. So the plot here is that Pham had some money and then he earned some more money. That's a problem about combining. So if he had $24.50 and he earned $12.50 more, we know that he had at the end of the day or after that time $37 after putting up the fence. So he had some and he earned some more, and it equals the total in the end. So this is a problem about combining. It has an addition pattern. Okay, let's look at problems about addition with combining that have an addition pattern. Some plus some more equals a total. So when you look at this, you have sum plus more equals a total. There are three numbers in the pattern. In a word problem, one of the numbers is unknown, as in this story below. Katya had 734 stamps in her collection, so she has some 734 stamps in her collection. That's the sum. Then her uncle gave her some more stamps, which we don't know how many more he gave her. But in the end, after she counted all those stamps, she now has 813 stamps. How many stamps did Katya's uncle give her? So you can see you've got an addition problem here. You could also create this problem. Remember the fact families. And now you could create this problem here. 813 equals, if you were to subtract, you could have 813 subtract m will equal 734, or you could have 813 subtract the 734 equals the m. And this is the only one that will get us how many she had gotten from her uncle. So she had some, she got some more, and it resulted in a total. Now we know, because we knew what the sum was, we knew what the total was in the end. We just didn't know what the sum more was going to be. So that's the unknown. Now we can figure it out by using that equation. So in this problem, it has a similar plot to the previous one. The plot is Katya had some stamps and was given some more. So in this problem, however, one of the numbers is unknown. Katya's uncle gave her some stamps, but the problem doesn't say how many. We use the four-step process to solve the problem. Number one, step one. Since this problem is about combining, it has an addition pattern. So sum plus some more equals a total. Then we plan that out. We can look at this. The pattern is sum plus some more equals a total. Your equation will be 734 stamps plus some more equaling 813 stamps, as I had done up here. This was the initial equation in step 2. Step 3, to answer the equation, The answer to the equation is the unknown number in the equation. Since the unknown number is the addend, we have to subtract 734 from 813. So this was basically step 3. This was step 3 right here. This was step 1, or step 2. We understood that it was an addition pattern. That was step 1. This was step 2. This is step 3. So then you just find your answer. In this case, we would take 813 minus 734 and get 79 stamps. You can check your answer. If you have 813 minus 79, it should equal the other number. So then we review the question and write the answer. Katya's uncle gave her the 79 stamps, which is what the sum more was. Another common plot in word problems is separating. There's a beginning amount, then some goes away, and then there's some that remain. Problems about separating have a subtraction pattern. So you have a beginning amount, some goes away, some went away, and then whatever remains is your final answer. So like B is the beginning amount minus some went away, A for away, equals the remaining. And it doesn't matter what letters you use for the pattern, but here's an example. Waverly took $37 to the music store. She bought headphones for $26.17. Then Waverly had $10.83. So here's your plot. She had some money, but some of her money went away when she spent it. So this is a problem about separating. Thus, it's a subtraction pattern. So here's your pattern. You've got a beginning amount, some went away, and then you still have a remaining amount. So here's your equation. $37 is what she went into the music store with. This is how much she spent, $26.17. That went away. Now what's remaining is $10.83. That would be the equation and the solution. Let's look at an example here. So if Jenny rode her bike on a trip with her bicycling club, after the first day, Jenny's trip odometer showed that she had traveled 86 miles. After the second day, the trip odometer showed that she had traveled a total of 163 miles. So how far did Jenny ride the second day? So if you look at it in step 1, Jenny rode some miles and then rode some more miles. So she had ridden some miles and then she rode some more miles. The distance of those 2 days combined give a total. Since this is a problem about combining, it actually has an addition pattern. So we're going to look at the step 2 here. The trip odometer showed how far she traveled the first day and then gave us the total of the first 2 days. So here's the pattern. She had some to begin with. She had 86 miles the first day. Then she went some more, which doesn't say how much more she traveled, but it does tell us what the total was at the end. She had 163 miles. So here's your pattern. Some plus some more equals the total. These are the amounts, the values that we have, and this is the unknown. We don't know that. So in step 3, we solve the equation by finding the unknown number. From lesson 3, we know that we can find the missing addend by subtracting 86 from 163 miles. So then we check the answer. So 163 minus 86 equals 77. In case you don't know how to do that, 86, you have to borrow, obviously, here. So this would be 13, this would be 5, and that would be 7. Then you have to borrow again here. That'd be 15 minus that, so you'd have 77 miles. Checking your answer, you just take 86 plus 77, and you get 163. To review the question, then you review the question and write the answer. Jenny rode 77 miles on the second day of the trip. The first day was 86 miles, second day was 77 miles. We didn't know that at the beginning. We just knew that there was 86 miles and then a total of 163 miles. Let's look at another example. On Saturday, 47 people volunteered to clean up at the park. Some of the people chose to remove trash from the lake. The remaining 29 people left to clean up the hiking trails. How many people chose to remove trash from the lake? So in this case, you have a pattern. There are 47 people, then some went away. This problem has a subtraction pattern. There was 47 people, and then some went away. Subtraction pattern. So we use that pattern to write an equation, and we can show it written vertically like this. You have a beginning amount, 47 people. Some went away. We don't know. It says the remaining people were 29. We don't know how many people actually went away, but we do know at the end of those people leaving, there were 29 remaining. So what we had at our beginning amount was 47. We don't know how many people left, but we know that 29 remain. So now you can figure that out. Find the unknown number by subtracting 29 from 47 and checking the answer. So if you take 47 minus 29, you get 18 people. You want to double check your answer, you take 47 minus 18 and you can get 29 people. Remember, you've got fact families. You could work through. This would be like the same as 47 minus 29 equals the number of people. You could have had 29 plus the number of people that went away equals 47, just like that one. And then you could have a reverse of this, number of people that went away plus the 29 that were remaining would equal 47. So there's three different, you've got your fact family there, two different addition and two different subtraction problems. Then you review the question and write the answer. The answer would be 18 people who chose to remove trash that day, using problems about separating there. All right, let's try this one. So following the four-step method, solve this problem along with each answer, including the equation you used to solve the problem. So in this case, when Tim finished page 129 of a 314-page book, how many pages did he still have to read? So in this case, you can see that we've got a 314-page book, and he finished page 129, so he still had to read a number of pages. We actually don't know how many pages are total or in the end, but we know what the total is. So it actually starts out like this: 314-page book. That's the total. And we can subtract the amount that he actually read, the 129, which then equals how many pages he has remaining. So in this case, you've got 314, subtract 129. I need to borrow. This would be 14. This would be 0. This would end up being 5. I have to borrow again. This would be 2. This would be 8. And we have 285. So that means, actually, and if I look at this, I was reading that wrong. It should be 185 pages would be the remaining amount that he has to read still. And that would be it on that. Let's look at a letter B here. The football team scored 19 points in the first half of the game and 42 points by the end of the game. How many points did the team score in the second half? So if you look at it, you can see that the football team scored 19 points. They had some, and they scored some more, but we don't know what that is. We don't know what that total is in the points. I'm just going to use M for more points. And then they ended up with 42 points at the end of the game. So now I need to recognize that I have to subtract 19 from 42. if I was to get m by itself, I would take 42 minus 19, and I'd end up with 3. This would be 12. This would be 3 here, 23. So the number of points scored in the second half would be 23 points scored in the second half. And I want to double check my answer. I just take 23 plus 19, and it should equal 42. And it does. So that means 23 is correct. Let's do letter C. Write a word problem about combining and then solve the problem and write the answer. So in this case, you need to have a word problem about combining. If you remember, word problems about combining would be something of this nature, where you have some and then you earn some more, or you get some more, and it equals a total. So your problem just needs to match that pattern, and there's no, I'll just check those. Everybody's answers will be a little bit different, but it might be something to this effect. Scott had $50, and then my next sentence might be, he worked 2 hours making 20 more dollars. So how much money does he have at the end of the day? Okay, and that would be it. That'd be something, and then I have to solve my problem. I can see that he had some, and then he had some more, and in the end, he's going to have this much total in the end. So that would be my problem, my work, and my answer. Solve the problem, write the answer. $70 at the end of the day. And I might want to label it at the end of the day. Okay, excellent work today, guys. And don't forget to do your WP 1 through 30. That's a written practice in lesson 11. And you can check your work in the Go Formative. Have a great day and keep up the great work.